Guys, Hi guys, this is Miss Raina, Handy Dandy Environmental Systems teacher here at C347 at MacArthur High School. I want to talk to you today about indoor air pollution. So we just finished our lab where you guys looked at some particulate matter in different areas of the campus, and we had a kind of interesting experimental design, just a very rudimentary one, and there might have been some ways that error could be introduced. That you could identify in your experiment. So as we're going through these different types of indoor air pollution, I want you to be thinking about possible sources of error in your analysis of your experiment and your experimental design. To start with, we've got a little bit of good news. So since the Air Quality Act, we definitely have a downfall, a downward trend in the different indoor air pollutants. And it's definitely worse in developing countries than it is in countries that are developed already. So we'll start to look at what this all means. For indoor air pollution, I know that you guys were speculating about some of the possible sources. Hopefully we didn't have things like tobacco smoke or radon gas here on campus, but I know you guys were able to identify some pretty small particles. I don't know whether they were fine or ultrafine, but it gives you an idea of what might be in the air here. Where in this building do you think there might be formaldehyde in the air? This is just kind of a schematic of the different kinds of indoor air pollution that you might find in your own house. So anywhere you see plastic, there are all kinds of things coming up out of that plastic. Your carpet is made of one of those polymers. A bunch of your shower doors, a bunch of your different appliances are made of those different kinds of polymers. Anything that burns or anything that does combustion or uses heat is probably putting some particulates into the air. If there's tobacco smoke in your home, it's definitely a source of introducing indoor air pollution. Another big source comes from your own skin, but it's not directly. Most people that are allergic to dust are not allergic to their own skin, they're allergic to the excrement of dust mites. So the dust mites eat the flakes of skin, and then their excrement causes an allergic reaction. Not the nicest thing to think about, but it's the truth. In other areas of the country, not so much here in San Antonio, there's a risk of radon pollution inside the home. So people have to keep detectors all over the house because radon is something that doesn't have an odor, it doesn't have a taste, you can't see it, but it definitely is radioactive and it can cause cancer, it can cause mutations in your own tissues if you're exposed. Here's a lung of someone who has emphysema, here's a healthy lung. It's not the most fun thing to look at. I understand that, it's a little bit graphic, but it's important to understand what are the effects of living in a high density air pollution area. So who would live in an area with such high density air pollution? Well, most of the time, it's not Americans. There are some Americans that have higher rates of exposure than others. So there are people that actually die of air pollution. And in a lot of cases, this correlates with population density. It, of course, is not a cause-effect relationship, right, necessarily between population density and death from air pollution, but there are some factors involved, most specifically the distribution of coal-fired power plants. The Clean Air Act in the United States identified 6 major pollutants, and it helped us definitely decrease the rates of these pollutants, both indoor and outdoor. It also authorized cap and trade, and I know that that's a controversial issue, and so I just want to reiterate that we're not learning opinions here, we're looking at statistics and what the results were. So there was definitely a marked increase in the trading system and a statistically significant decrease in the emissions of those things that were tracked by that trading system. Here are some ways that we can reduce the amount of air pollution from coal-fired power plants. One is called an electrostatic precipitator, And it basically uses that static electricity to attract those teeny tiny little particles and get them out of the smoke that's being propelled into the air. And that way, the exhaust from the coal-fired power plants is a little bit safer. We still have to consider where those particles are going to go. How are we going to ultimately get rid of them? It's the same issue we have with something called a wet scrubber. So a wet scrubber will literally spray all that smoke that's going out into the air, all that exhaust, and hopefully the wet scrubber will catch some of those finer particles, but then there's the issue of how do you dispose of that waste? We have a couple of ways that we can control air pollution from motor vehicles. And I know that this is a kind of like confusing place to put this information, but what you have to remember about indoor air pollution is that the air in your building is coming from the air outside, and it's a lot less ventilated than the air outside. So whatever is affecting us outside is being concentrated inside. It becomes a whole lot more important. As long as we're thinking of motor vehicle air pollution, I just want to point out there are a whole lot more things that we can do on the prevention side than options we have on the cleanup side. So we can have a much bigger impact on prevention than we can in cleanup. There actually hasn't been a whole lot of legislation in reducing indoor air pollution apart from banning smoking. And again, here are some possible ways of reducing indoor air pollution on the prevention side as well as on the cleanup side. All right, so thanks a lot for listening and watching the little video, and just be prepared to know this stuff on an upcoming assessment, whether it be a quiz or the unit test. Thanks, guys.